Everyone. So for notes today, we're gonna just do a couple quick things to fill in on page 111. You're on page 111. So we're gonna talk about these things called domain and range. All right, the domain is the set of all x values, or as we saw the other day, the inputs. And the range is the set of all y values, or the outputs. Okay, and so when we talk about domain and range, that's what we're talking about, the x values and the y values that are part of a relation or part of a function. Okay, and so we have these two definitions here, discrete graph and continuous graph, and you can see it already is filled in there. So a discrete graph is when it's graphed with individual points and they're not connected by a line. An example you can see below is problem D. That's an example of a discrete graph. Those are separate points, they're not connected by a line. And so when we state the domain and range, we use set notation, which are these kind of curly brackets. And when we get down to those problems, you'll see what that looks like. Okay, a continuous graph is one that's drawn with a straight or curved line. It's connected. And so that is something like A, like B, like C. They're not separate individual points. They are a line drawn that's continuous. So you could take your pencil and draw over the line without picking it up. That's a continuous graph. And when we do the domain and range for that, we use something called interval notation, which you guys know what that is. We've been using it. And so example 3 here is going to show us how to determine the domain and range for each of these functions and using proper notation. So first, let's look at A. A is continuous. It asks us continuous or discrete. It is continuous because it's all connected, right? Think continuous connected, continuous connected. And so like this is made up of a bunch of different separate points, but they are all connected by a line. Okay, so that is continuous. All right, so the domain, these are the x values that are part of this graph, that are represented in this graph. And so I'm looking along the x-axis and trying to figure out what x values are on the graph. Right, so if I went to 1, that's on the graph. 2 is on the graph. 2.5 is on the graph. All these x values are on the graph. All the way from the right all the way to the left. All those x values are represented on the graph. I could pick any point on the graph and show that it's got an x value on this axis, right? So all these x values are part of this function. And so the domain is like every single number. Well, how do we write that? Just like we did in when we're graphing inequalities. It's like we shaded the whole number line, and so we say parenthesis negative infinity, comma infinity. That means all the numbers. Let's look at the range, and we'll use a different color for range. All right, so for the range, I'm looking at what y values, the range of the y values, what y values are represented on this function. Okay, and so if I'm looking, like all the points on the graph, these are all the y values that are taken up, that are shown on the graph. And if I just went through all of them, all the way up to the top, all the way down to the bottom forever and ever, I'd hit every single y value. And so our range is all the y values. Well, guess what? We say negative infinity to infinity for that also. Okay, let's look at B and see how it's a little different. All right, in the domain, I'm looking at the x values, right? And so on this graph, which is this kind of like upside down U shape, right? We call that a parabola. I'm looking at all the x values that are on that, are represented, that are part of it. And it's all of them again, all the way to the left, all the way to the right, because that arrow means this graph keeps going forever and ever. And it's not going straight down, it's still going to the side also. And so in a parabola like this, all the x values are hit. So once again, we go negative infinity, comma infinity. But how about the y values? All right, well, let's see. Let's pick a few to try. How about -4.5? Is that on the graph? Yep, a couple places. -2, is that on the graph? Yep. How about 0? Is that on the graph? Yeah. All these y values down here. How about 1? Yeah. 2? Yeah. 3? Yeah. 3.5? Yeah. 4? Yeah. What about 5? Not on the graph. 4.5? Not on the graph. 7? Not on the graph. Oh, so it stops. So all the y values are represented until we get to 4. And so we go, again, smallest to biggest, bottom to top, smallest to biggest. So for y, the smallest ones down at the bottom, that's -infinity, and that is included in the graph. But all the way until we get to the top at 4, right? That's our top. So we say it's a 4 bracket. Let's do another one. All right, go faster on this. Here we go, domain x. Let's see. All the x values, which are the ones that are represented? Well, this goes forever to the left, goes forever to the right, and it hits all of them. So my domain, just like the other ones we've seen, -infinity, infinity. Range, that's the y's. Well, that one goes down forever, and that one goes up forever. So my range is all the y values, -infinity, infinity. Okay, D. Whoa, hold on. We forgot. Those both are also continuous, B and C. But problem D. This one's discrete because it's separate dots. Instead of continuous connected, this is discrete. Disconnected. Actually, that kind of works. Discrete, disconnected. Okay, so domain, and we are told to write it with set notation. So the domain is all the x's, the range is all the y's. So what we do is we just make a little curly bracket, and I like list off all the x values that are points. So this x value is -4, -3, 2, and 4. So I just make a list. -4, -3, 2, 4. Just the x values, that's all. I like to go left to right. And then top to bottom, what are the y values? Well, let's see. That's -3, that's 0, that's 1, and that's 2. All right, I'm looking at y values now. So I do that in order: -3, 0, 1, 2. And that's my range. Okay, problem E. This one is connected, so it's continuous. Domain is all the x's, and like what you want to get to the point is where it's kind of pretty quick. You're like, okay, left, right, it takes all of them here. Left to right goes forever to the left, forever to the right. That's -infinity, infinity. But the range, okay, so again, you're looking bottom to top, like start at the bottom and go up, and like, are these points down here represented on the graph? They're not until I get to what value? -1, looks like. So -1 is the first time I'm represented on the graph, and I could, then from there, it's gonna go up forever. All the y values are taken up, like every y value here I can find is represented on the graph somewhere, right? Even the y value of 2.5, well, that's there. What about the y value of 3? Well, this graph goes up forever, and it goes up forever. So yes, the y value of 3 is represented. So we start at the lowest y value is -1. So I go bracket -1, infinity. All right. Problem F, real quick. Continuous or discrete? Well, that's separate points. If we were to graph it, we'd see that it was separate points. So for my domain, I just list the x's: -2, -1, 0, 1, 2. And for the range, we get 2, 3, 4, 5, 6. I like to go in order, smallest to biggest, left to right. 2, 3, 4, 5, 6. All right. That's all for our introduction to domain and range. Thank you for watching.